I'm going to talk today about a topic that interested me a lot during the work on my thesis. First, I could just say what the thesis is about as such. So that's about bias and discrimination in clinical decision support systems based on artificial intelligence, as you can see here from this snippet. And that's a topic that combines some very core machine learning, very technical issues with some legal principles where some of the same language is used across these two disciplines of machine learning and law. And it's been challenging and also very fun to try to connect these disciplines, even though I have to say that as a lawyer, I will always have the legal perspective, and I don't have a machine learning background. So this is very much a lawyer trying to connect these topics by building a bridge the way a lawyer can build such a bridge. But now I need the help of you guys to further develop some of the ideas that came up during the project. So this is not really like a roadmap or a very practical framework for assessing an AI system's compliance with the laws of decision making, but it's more of an exploration of the possibilities that I see when I read about some of the techniques and methods that exist within machine learning, and I combine that knowledge with knowledge of what kind of information and explanations we need when we are assessing AI systems in the light of various legal requirements. So I'm going to rise this talk, lift it up to higher level of abstraction compared to the PhD thesis as such, and point out some methods that I came across that I thought it would be interesting to further explore to see if they can be used the way that I imagine to assess an AI system's compliance with certain laws. So normally I talk to lawyers and explain what I have learned about machine learning and how AI can be used for decision making and all that stuff. But now you guys in this room, probably most of you know all that stuff. So now my job is more to explain how law works. So on the agenda today, I have how law works very basically as a start, the first point. Before I will talk a little bit about what I mean by the laws of decision making, so that we can move on to looking at some of the more technical methods that I have identified after discussing with Robert and also Kristoffer Wikström and a lot of other people from machine learning, and they have pointed me towards some references that I have then explored in my research. So very basically, why do we have laws? It's an important question to ask at the beginning, because we are going to talk about what is the difference of a more traditional situation where we apply laws in the courtroom, for example, and the kind of assessment that I'm talking about. So this timeline illustrates that there's a political process at the beginning, which fundamentally asks the question, what kind of behavior do we want in our societies? Then there's a political debate, and laws are eventually passed. And one of the most important purposes of law is to influence behavior. However, sometimes things do not go as expected, which is why we see this explosion happening on this timeline. Something goes wrong or people disagree, and we use laws to solve disputes. So these are, in this context, the two most important ways that laws are used to influence behavior and to solve disputes. However, influencing behavior is perhaps more easily achieved when we make laws for humans, because we have some ideas of how what influences human behavior. So these laws are directed towards individuals, companies, public agencies, AI developers, AI users, of course, but they are not necessarily very well fitted to influence the behavior of an AI system as such, which is like a fundamental challenge in this area. And by an AI system, I mean a computer program where a model based on machine learning is implemented and serves as decision support is the most relevant application in the context of this presentation. So that's challenging to begin with, that we don't always know exactly how these AI systems work, and we don't know how to influence their behavior as such. We can only try to influence the people who develop and use them, and then we can try to test them to see how they behave in the real world. And this assessment that I'm talking about, the compliance assessment, is, as I see it, something that could be a part of a testing process where you test and evaluate an AI system before you deploy it. If you want that system to be accepted and used, the testing procedures should demonstrate that it also complies with certain laws. Now, as mentioned, the use of laws to solve disputes is one important purpose of law. This image here is, of course, generated by an AI, and I didn't want to use it because it's so incredibly stereotypical, but I thought it's a good point that it illustrates the bias that is often inherent in AI systems. So this model that I used just assumed that a judge, which is what I wanted a picture of, is this white man with a white beard sitting in his office with a big mahogany chair or something. However, in this case, the judge is thinking about how to deal with a case concerning an AI system that went wrong, or someone who's claiming that the AI system discriminated against them or led to them not receiving, for example, a benefit that they are entitled to. And this is sort of different from the assessments that judges are used to, where they typically have case files. If there's a dispute concerning a person or a company that didn't get the decision that they wanted from a public agency, for example, you have witnesses explaining the decision-making process and saying what kind of considerations they made during the process. And you also have documents showing what was discussed in this process. And it's all very easy for the judge to relate to this kind of human political decision-making process. But that might be a bit more difficult if the case concerns a machine learning based model. What kind of considerations did that model make, so to say, when making a decision. So this is one of the reasons why laws that are being created now, specifically for AI systems, they require certain assessments to be made before the system is even used in practice. So instead of relying on these cases coming up before the courts and the assessments of judges retrospectively, the laws for AI decision-making are aimed at ensuring compliance before deployment. And that's why this topic of assessing compliance in an AI system is so important going forward. And this context of assessing something before it is deployed is different from the retrospective assessment that a judge makes, because we are now asking what is going to happen or what is likely to happen when this system is deployed. How is it likely that the system is going to behave, rather than the more traditional judicial assessment where you ask what happened and did what happened violate any laws. Just some examples of decisions that AI systems can be used for in theory. Medical decisions such as diagnosis, prognosis, treatment recommendations, and even prioritization between patients is imaginable. There are also several other decisions within the public sector where research is being conducted to see if AI can be used. For example, fraud detection, where you have profiling, trying to classify persons who represent a higher risk of committing fraud, for example, and the determination of welfare benefits or immigration applications. Just a few examples just to demonstrate that these are potentially decisions that are very important for individuals, and where the laws of decision-making require certain explanations, and they require that the decision-making process is fair, to put it in a slightly simplified manner. And some of these laws also apply to private sector decision-making. So let's look a bit closer at the laws of decision-making. Generally, these are three important categories of legal requirements for decision-making. So I'm introducing this because we're going to get to the discussion about how to assess whether an AI system is compliant with these requirements. Especially in public sector decision-making, there's a requirement of neutrality and objectivity. That's the more general way to put it. In Norwegian law, we have this rule that is called no irrelevant considerations, and I'm not sure exactly how that rule translates to English, but quite literally, the rule says that when making decisions in the public administration, you may only rely on relevant considerations. So if a person can claim that someone took into account a factor that they shouldn't have taken into account, whatever that is, that could be reason for complaining and demanding legal remedies for the decision. And in the extension of this requirement of no irrelevant considerations, there's the general equal treatment principle in public sector we need to understand what cases are like. And this raises the question of comparability. And I will return to how certain methods within machine learning may be used to assess comparability between cases when testing an AI system. There's also the principle of non-discrimination, which was the main focus of my PhD thesis. And this principle generally says that certain personal characteristics are prohibited as a starting point. This means that there are a few characteristics that are always irrelevant considerations, unless there is a specific exception in the law. And this means that it's very important to know whether an AI system uses any of these characteristics as a feature variable. And that's also something I think that machine learning is already very engaged in trying to figure out how to determine whether a certain factor is used in a neural network, for example, where you cannot just directly observe the feature variables, but you have to use certain techniques to try to figure out whether it's more or less likely that various features are used by the system. A very interesting topic that I will return to at the end here. Just want to mention also the explanation requirement in public sector decision-making, which is linked to these two other requirements. And typically the most important factors should be explained. So this is also a legal reason why the machine learning community should definitely continue to develop these methods so that AI can be used in public sector decision-making and comply with the explanation requirement, or enable public officials to provide an explanation that the citizen is entitled to. Yeah, so the irrelevant considerations basically means that you need to show that decisions are made based on considerations that are lawful, excluding those that are outside the scope of the relevant law. So if you're making a decision based on the Norwegian Public Administration Act, for example, often there will be certain, we call them legislative aims. So there are certain purposes that the law is supposed to serve. And those are the most relevant considerations. So an AI system for determining welfare benefits, for example, somehow needs to integrate those considerations and not other considerations. And I guess it could be difficult to distinguish between the two sometimes. So it raises the question of what considerations an AI system actually makes. And some of this probably sounds a bit abstract or not very clear to machine learning researchers and practitioners. And that's because we have to keep building this bridge between law and machine learning. Because there's always going to be this gap when you explain legal requirements. They are not articulated with machine learning techniques in mind. So they can only be formulated with clarity to a certain extent. And then we need to start exploring, okay, what could this mean in the context of assessing an AI system? Or rather, the models, the individual models that are used within an AI system. Specifically in relation to non-discrimination law, it's very important that we are able to understand whether the characteristics that are defined as protected characteristics are being used by an AI system. Some examples are sex or gender, ethnicity, sexual orientation, and religion. So generally, it is relevant to understand and important to know if these characteristics are being used. With deep neural networks, for example, it's possible that certain factors which are correlated with these characteristics are used in a way that perhaps corresponds to relying directly on one of these characteristics. And I will develop that point a bit further in the next slide. But it's also important to note here that even if we cannot see that an AI system uses one of these characteristics directly, non-discrimination law says that the outputs that are undesirable should not be distributed in a way that is disproportionate to the detriment of a group defined by these traits. So even if we cannot see that an AI system relies on gender, for example, we should be able to define the outcomes that are desirable for an individual in a decision-making context and the outcomes that are undesirable. This is something that I discuss in my thesis, and I use the example, one of the examples is diagnostics, where you always want to have a diagnosis that is correct. Of course, this assumes that you have a ground truth that is reliable, so you know what is correct and what is not correct. But just for the sake of illustration, you could, when testing an AI system, use a test data set where you try to see the distribution of false positives, for example. And then you could try to figure out whether there are more false positives for women than for men, or from ethnic minority groups compared to the majority. So that's one of the considerations that should be included in a compliance assessment before deployment, at least according to my conclusions and my analysis. Okay, now we're getting to the stuff that machine learning practitioners and researchers may have heard about and recognize in this slide. Because when I was studying non-discrimination law and its application to AI systems, I came across these methods of probing whether a neural network includes certain concepts. And these are concepts that are not directly observable in the training data or the input data. But there is, as you guys probably know, at least an assumption that observations of hidden units in neural networks may include human interpretable concepts. And they are called individual latent variables in this research by David Bao and others from 2017, where they looked at image data, I think, or like graph structured data. But there's also research that Christopher tipped me about that shows that the same kind of occurrence is very possible in more tabular data. And I think it's really interesting that there are certain techniques for trying to establish what concepts there are within a neural network. For example, there is the quite famous paper from 2018 by Bin Kim and others, testing with concept activation vectors. for me, as a lawyer researching non-discrimination law, this was really interesting because we have this distinction between direct and indirect discrimination, where it does matter if a decision-making process uses a concept such as ethnicity or gender directly. And I would say that if from a technical perspective, you can say that this is a feature variable, then it's used directly in the decision-making process. And the way I understand it, I think that if you can find these concepts as latent variables, I think that amounts to relying directly on, for example, the concept of ethnicity in a decision-making process. But I'm not entirely sure because I haven't seen any research where they try to use these methods of probing these concepts with a legal assessment in mind. So that's something that I'm not aware of anyone who's done. So please let me know if you know of research where this has been done. I've only found other contexts and other purposes of trying to figure out the concepts that are used as a latent variable in a neural network. But I think also the research by Strumke, Slavkovic, and Stachel is very supportive of the idea of using this type of testing in the context of a legal compliance assessment, because they talk about concepts such as whether a person is depressed or in a vulnerable state. And that's starting to look more like the types of concepts that can have a legal implication. So that's something that would be very interesting to discuss further. And then once we have mapped as far as possible the feature variables that are included in an AI system, in a machine learning model or a deep neural network, it is also legally relevant to ask how important is each feature relative to the others. I understand that there are several different methods for trying to sort of quantify the relative importance of a feature variable. I refer to Goyal and others measuring the causal concept effect as one example of such a method. And again, this research within the machine learning community is being conducted for other purposes than assessing the lawfulness of an AI system. It's very much related to the whole explainable AI discourse, where explainability techniques are being developed, which is very good. But I think if the legal community and the XAI community communicated a bit more with each other, then maybe the explainable AI efforts could be more directed towards the kinds of explanations that you actually need to demonstrate legal compliance. And as I mentioned, in public sector decision-making, you're often expected to show what were the most important factors in a decision. And how can you do that if you cannot demonstrate the relative importance of feature variables in a model? I think there are a few instances where you need to come up with such an explanation. And then there's going to be the whole debate about whether the explanation is reliable and so on. But I think that's a topic where there's an overlap between some methods that are being developed and what we need to know when assessing AI from a legal perspective. Okay, I'm already at the last slide. The other area of potential overlap that I discovered is comparability. And again, I think that comparability is something that is often considered by some machine learning methods for the purpose of ensuring a general level of explainability. So when testing an AI system, you use a data set, and I know that there is a certain interest for trying to show that, oh, these cases are similar and these cases are different. For example, if you are going to use an AI system to come up with medical recommendations, you might want to show the clinician that this recommendation makes sense because here are 10 patients that are similar to the patient that you are now making a decision for, and this is what happened to them. However, in the context of the loss of decision-making, the purpose of determining comparability is often to show that people are being treated equally if they are comparable. And we often use the term comparability in law because we are trying to figure out if cases are comparable when we look away from the protected characteristics, unless those characteristics are lawful in a certain context. This is a bit different from how this has been approached, as far as I can see, in machine learning literature, where there are often techniques developed for determining similarity, but then you take into account all of the information that you have. And sometimes in law, we want to take away certain factors that we don't want to take into account, and then we want to determine, are these patients in a comparable situation disregarding these factors, which of course leads to a difficult conversation about what are the relevant factors for any clinical decision, but let's not go into that here. Just wanted to mention the methods that I identified that could be relevant also in the context of a legal assessment. Different kinds of cluster analysis could be interesting. Propensity score matching, which I understand is something that is used a lot in medicine, specifically to make sure that you are in control of confounding factors, and various methods for counterfactual testing, where you change the information about the patients, for example, in a test data set, and you run the model again and again with small adjustments to see what happens, and maybe to see whether they switch a cluster, and that's maybe more relevant in relation to feature importance as well.